Hello, good morning. Welcome for our next episode. We are here just as we continue to our blog here in Hate It or Love It. So this is a cliche that we have here for learning mathematics. As we have discussed earlier that some of our guys find it hard or have no interest in learning mathematics. But you see, it's part of our daily lives. Either you hate it or love it. Okay? So one thing is you have to get not compromise on that one is to practice all the things, or you have to embrace the things of that matters which you hated most. And the things there's a mutual understanding between the subject and yours also. So you have to coordinate each other on that. I'm talking about your interest in learning mathematics. It's very hard for you. Just try to love it and find ways of the qualities, the characteristics, and you go deeper on that one and try to search for it, learn for it, and practice it. Learn the principles and practice the principles into applications. That is the technique. And if you do not get it for the first time, you have to try it on the next time, second time, third, fourth, fifth, and sixth. It is also as we go back to the previous innovators, the previous theoretical mind that we have in the past. They keep on practicing and practicing the search for it, the search the meaning, the logic, and the validity of their theorems. And they practice it and they test it and they are satisfied. And you see, they are successful in any way. So now, as we continue on that one, on this blog, I hope and I do praying that all of you guys who are watching these videos, there are plenty of blogs who are dealing about mathematics. I hope you just get enjoy on this one as you get your struggles in learning mathematics. You see, the basic principles, techniques of this one is to learn how the properties, how the necessities and the principles behind of this one you have to put into practice so that it's not difficult for you when you apply these principles into basic solving calculations. Okay? Now, we have learned already the principles and some of the properties that we have for this algebra. Okay? Now, algebra, it's not only numbers, but we are integrating this one with a variable, letters. Now, letters and numbers is just an expression. It's what we call here in algebra is an algebraic expression. Algebra is a representations of letters, mostly in variables, so that we could get the numbers. So there's a combinations with a letters, a variable, and a numbers. Okay? Now, when we come to get with algebraic expression, you could dissect that one, and it will give you the exact the supposed result that they are going to equate or to evaluate once you get involved with these operations. Now, the operational symbols that I've discussed earlier in our blogs is with the use of addition, subtractions, multiplications, division, and exponentiation. Okay? Now, algebra. Now, shall we say on this one here, if we say 2x, this for a term. Okay? If we say also 3y plus x. Okay? If we say a b plus 2x cubed from y squared plus 3. Now if we say also here again x4 or 5x4 plus xy to the third, then plus 3x, so we say x cubed y plus 8. Okay, these are the algebraic expressions. Okay, guys, you know the word term. You know the word term. Okay, terms, or make it singular, term. When we are dealing about these equations in algebra, we will get to know about of how many numbers, how many sets of numbers, how many combinations. So you see, in algebraic expression, it is the gathering, it is a gathering of letter, variable. Okay, variable plus real and real numbers with the combinations of positive, negative. This is the operation, multiplication, and we have also division, we have the exponentiation. Okay, so now guys, when we say this one here without the operations of positive and negative, we call it first term. Okay, this is the first term. When we say 3x plus x, 3x is the first term, x is the second term. Okay, when we say 2x here, we say as a monomial. Okay, monomial. So when we go with the plus, the operations here with the positive, the addition, there are two terms already here, 1 and 2. So we call that binomial. Okay, so when we are getting this one here, we have first, second, and third, which is the real numbers. We call that trinomial. Okay, when equations, when an expressions begets more than 3 or 4 or 5, it becomes a polynomial expression. Okay, algebraic. We have first term, we have second, we have third, and we have 4, and so and so it becomes a polynomial. Okay, you understand? So this is the algebraic expressions that we are going, and plus the radicals of that one, and the combinations of exponential terms. Okay, now we will discuss it later about the exponential term. Now, how about the power? Now the power, are you familiar on that one, the power? Okay, the power. Now we see here power and exponent. It's very important for us that you will know also what are power and exponents. For example, if I will be using A as the numbers, go like this here, and if we're going to multiply by itself into how many times, shall we say 3 times, we will raise this one to n time, or what we call it 3 times here, we call it 3. Okay, okay. Now if you are going to these expressions we have here, is this one here, is we call it a base. Now this one is, we said, an n time, or raised to the n power, raised to the n power. Guys, this n here pertains to the exponential form. How many times this a, letter A, raised to the n power? This is the exponential form. Okay, this is the n time power, or shall we say n time, and this is the base. Okay, now shall we say if we apply this one here in numerical factor, we have here, if we use this one 2, we are going to multiply 2 at the third times, so we'll say here 2 raised to the third power. Okay, let's say, now you see 2 raised to the third power, we'll say here 2 here is 4, 4 times 2 here is 8, so we'll say here 2 raised to the third power, we'll say 8. Okay, now if we say here another one, say another one here, 3. 3, we are going to use this one in 5th time. So we say here raised to the base of 3 raised to the 5th exponential 5. Then we have here 3. 3 by 3, 9. 9 by 3, 9 times 3, how much? How much? 27. 27 by 3, how much? 2 by 3, 6, 7, 8. 81. 81 by 3. 3. 3 by 8. 2, 16. 24. 24. 2. 3 raised to the 5th power is 243. Okay? Now, guys, perhaps you're familiar already the power and exponent. If any numbers multiply by itself, we can get this one in the exponential form. Okay? There are so much, as we go further, we will discuss this one, the law of exponents. Okay? Now, guys, in response to that one here, have you known this one here, that on this one here, five x4 plus xy squared plus 3x squared plus 8, you see here, 5, if we are going to put here, explain to you, now this term here, if we say 5x4 plus xy squared plus 3x cubed y plus 8, we see here 5 is the numerical coefficient of x. Okay? 5 is the numerical coefficient. We see numerical coefficient. Okay? Now, this one is understandably, it is imaginary one. Now here on this one here, this one in the first term here, we have the numerical coefficient here 5, we have 1 here, we have 3, the other one is just constant, we have here 8. Okay? But let's say here, we call this one in the laws, still here coefficients. Okay? Now, guys, are you ready? Let's go to the laws of exponent. I believe it's clear enough on this one. And what you have to do is to practice, 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 practice until it's getting very easy for you on this one. You get clear? And you have to help this one in the unconventional way. Just getting puzzles and get to use with the math or any arithmetical means that you would enjoy using any numbers. Scrabbles, used by numbers. Puzzles, use of numbers. Number game. Okay?